anti-clockwise moment. What will be the clockwise moment here? F2 into D2. So what principle, according to principle of moments, F1 D1 is equal to F2 D2. In this case, let's apply the principle of moments to this case. So the body is fixed at this point. So anti-clockwise moment is F1 into D1. F1 into D1. What will be the clockwise moment? Sum of clockwise moments. F2 D2 plus F3 D3. So F1 D1 is equal to this sort. So sum of anti-clockwise moment is always equal to sum of clockwise moment in case of principle of moments. What is a couple? A couple is a two equal and opposite parallel forces not acting along the same line to produce a turning effect. It is a special case of moment. As you can see here, this two forces are equal and opposite, and if this force moves like this and this force is moving like this, so it is producing a turning effect. So it is a special case of moment, and these two are equal and opposite parallel forces. A single force applied to a body fixed at an axis doesn't cause a turning in a body, as we have already seen many examples. Turning is always produced by a pair of forces. In the examples we have seen before, turning is due to two forces. One externally, which we have applied, and second is the reaction force at the fixed end. The reaction force is equal and opposite to the applied force. Remember Newton's third law. What does it state? To every action there is an equal and opposite reaction. We had already seen this diagram previously, turning effect example, but we didn't see that there are two forces which always act on, which produce a turning effect. Suppose this is moving here, so this hand, the force is applied this side. Similarly here, what happens in bicycle? If we apply one force here, another force is applied here, and these forces are equal and opposite. So for turning effect, a pair of forces always act, and the pair of forces which act and which are equal and opposite and parallel to each other and doesn't apply in the same line is a couple. Similarly here, forces are being applied. Here we apply a one force and another force is exerted here, reaction force. So what is a moment of couple? Moment of couple is equal to the product of either force, one of the force, and the perpendicular distance between the two forces. Here what will be then? It will be the moment of forces, one of the forces F, or you can take this one or this one. One of the forces into the distance, that is AB, or I have written it as D. Let's see this one. Moment of force at the point A. Let's see, moment of force at the point A will be how much? Force F into distance from the axis to this. It is OA, right? We have written OA, and it is turning anti-clockwise. Similarly, force at the point, moment of force at point B will be F into OB, and that is also anti-clockwise. So total moment of force of couple is F into OA plus F into OB. That becomes F into AB, that is F into D, anti-clockwise. So when we have to take the turning effect or torque of a couple, then remember just one force, either one force into distance between the two forces. That is moment of couple. Now what is equilibrium of bodies? As the name suggests, equilibrium means equal, right? When a number of forces acting on a body produces no change in its state of rest or motion, the body is said to be in equilibrium. When the body is in equilibrium, sum of clockwise moment is equal to sum of anti-clockwise moment. As you can see in this example, what happens? Person A is moment. Let's calculate. Force into perpendicular distance from fulcrum or the mid-axis. So 400 into 2, that is 800 Newton meter. Similarly, person B's moment is again 800 Newton meter. So person A's moment is equal to B's moment. So clockwise moment is equal to anti-clockwise moment. So the seesaw is in equilibrium. So if number of forces also act on this body, then also it remains in a stable or balanced position. Equilibrium of bodies mean in a balanced position. There are two types of equilibrium. One is static equilibrium, another one is dynamic equilibrium. First, static equilibrium, when a body remains in state of rest under the influence of several forces, the body is said to be static equilibrium. Let's see this example first. This example is a book example. What happened? A book is placed on the table. So, a book exerts a weight of the book is exerted on the table, which is given as Fg. And then what happens? An equal and opposite reaction force is exerted by the table on the book, that is Fn, normal reaction force. So the book remains in stable position because plus F minus F. What will be the equation? Plus F minus F, and if they are the same quantity, it cancels out. So the book remains in a stable position. Similarly here, what happens? A person standing on the ground exerts a weight of W. The person's weight is W. And then that is a force exerted by the person on the ground. And then from the ground, an equal and opposite reaction force is exerted on the person. So this also cancel out. Weight cancel out with the reaction force. And so the person stands stable on the ground. But in case of a moon, where scientists go, you can see that the scientists cannot walk properly on the ground. They feel unbalanced. Why? Because the reaction force which should be exerted by the ground is very less, or the gravity or the force which is exerted by the ground of the moon on the person is very less, so it doesn't cancel out. So the person will float in the surface of the moon. What is dynamic equilibrium? When a body remains in the state of motion under the influence of several forces, the body is said to be in dynamic equilibrium, as in the case of a solar system. Even the planets and the sun are under several influence of forces. They remain in the state of motion all the time. Now, from these all examples which we have studied, another example for dynamic equilibrium is a body moving in suppose a body is moving with a constant height, like an aeroplane which moves at a constant height with upward lift on it, balances the weight downwards. So from all these examples that we saw, we knew that there are two conditions which must be satisfied for the body to be in equilibrium. First, the resultant of all forces acting on the body should be equal to 0. How can we know this? See, plus F, suppose a bowl is here. Suppose this is a table and a bowl is put here. Now suppose you have applied here 3 Newton force, right? Here is a person who is applying 3 Newton force with his hand to the bowl, and here are two babies which are applying 2 Newton force this side and another 1 Newton force. So what will be the total force acting on this cup? Let's see. 3 Newton from this side and from the other side 2 Newton plus 1 Newton. That is again 3 Newton. So what will be the resultant force? 3 Newton minus 3 Newton, that becomes 0. So the resultant of all the forces acting on the body should be equal to 0. Then second condition, the algebraic sum of moments. Whenever moments is involved means there is a turning effect. Turning effect is produced. Moment is torque or turning effect. So algebraic sum of moments of all forces or torques acting on a body about a point of rotation should be equal to 0. As you can see here, Here what will be the weight is 100 and the distance suppose here is d. This much distance is d. Here the distance is again d. Now let's calculate the moment. Moment, what we have studied, anti-clockwise moment is equal to clockwise moment. So this one is anti-clockwise. So what will be the weight? Suppose the weight is 50 plus 50, 100 Newton into d, right? The distance. And what will be the moment here? Again 100 into d. So what will happen? Clockwise moment is equal to anti-clockwise moment, right? So when algebraic sum is equal to 0, so if I take it to this side, what will happen? 100 Newton into d minus 100 Newton into d is equal to 0. So algebraic sum of the moments of force is 0. When these two conditions are achieved, then a body is said to be in equilibrium. Thank you for watching this video. If you have any questions, please leave them in the comment section. And if you have understood the concept, please like my video and subscribe to my channel for more updates.